So today I'll be discussing regarding the entrance of electrostatic potential and capacitance. Let's see that. So I'm going to share the page, share the entire screen now. Yes, the first question. N identical droplets are charged V volt each. If they coalesce to form a single drop, then its potential will be. So let me know whether you'll be able to do it or not first. But I'll just check my pen whether it's working. It's working fine. Just switch off my video so that it'll be easy for me to write it on the laptop. So whether you're getting it, please let me know. The first question. Or shall I do it? See, the basic way of doing this question is the first one is potential. The moment we see potential, what is the basic formula which comes into our mind? 1 by 4 pi epsilon naught into Q by R. Correct? This is the basic formula. But here there are how many charges are there? Here there are n number of charges. Correct? N identical droplets which are to be volt each. And they are forming what? A single drop. And all of these drops are what? Spherical drops for us. What kind of drops? Spherical drops. In the sense, we know that the area of a sphere is what? 4 by 3. Or the volume of sphere is what? 4 by 3 pi r cube. Correct? 4 by 3 pi r cube. Yes, and how many droplets are there? N droplets are there. So that is equal to what? The new thing. And they are forming to form a single drop. So single big radius. So 4 by 3 pi r dash cube or r1 cube. Which one you feel like? Okay. So from this, what will get cancelled? 4 by 3 pi will get cancelled. Yes. And what will be my r dash or r cube from this? R cube is nothing but r dash cube by n, or this r dash cube is what? N r cube. Correct? R cube is nothing but, or my r dash cube, or if you want, I'll write it r1 cube. This r1 cube is nothing but n r cube. Okay. So once I am done with this, what is my r1 cube root on both the sides? N power 1 by 3 into r. N power 1 by 3 into r. So my r is nothing but n power 1 by 3 into r, this one. And guys, if you're not able to understand, no need to worry. I'll be helping you out with the same. So no need to worry. First step is what? If you want, I'll just clear it out, everything. Volume of the sphere, correct? 4 by 3 pi r cube. N droplets are there. it is together forming a single big droplets. 4 by 3, 1, R1 cube. I'm cancelling these two things. 4 by 3 pi. So what is my R1 cube? R1 cube is equal to N R cube. Taking cube root on both the sides. Correct? If I'm taking cube root on R1 is equal to N power 1 by 3 into R. But the question is potential. So we all know the potential formula. What is the potential formula? 1 by 4 pi epsilon naught into Q by this new one, R1. Correct? That's our big droplet. So instead of R1, what I'll substitute? Correct? What I'll substitute? This N power 1 by 3 R. Correct? And here, how many charges are there? N number of charges are there. That's why we're multiplying by N. So this is going to become 1 by 4 pi epsilon naught into NQ. What is my R1? R into N power 1 by 3. The same thing I'm going to substitute here. R into N power 1 by 3. So NQ divided by R in power 1 by 3. And this is my 1, N power 1, and this is my 1 by 3. Correct? So I'll be getting what 1 by 4 pi epsilon naught into, this is my 1 minus 1 by 3, I'll be getting N power 2 by 3 into Q. So this is basically, what is this? This is only my voltage. So N power 2 by 3, N power 2 by 3 into V. Option A is the answer. Option A is the answer for this. Is it clear for everyone? If it is not clear, I'll be helping you out on the same. Don't need to worry. Okay. Yeah. Next, let me clear it out. Second one. A parallel plate capacitor with air between the plates has a capacitance 10 picofarad. Pico meaning 10 power minus 10. Okay. If the distance between the plates is reduced by half and space between them is filled with substance of dielectric constant 4, is how much? This is the question. How many of you don't know how to do it? If you don't know how to do this, just message me in the chat option. Okay, fine. And I'll do it on the board only. One second. So first thing is parallel plate capacitor. So we know the formula for the parallel plate capacitor. That is nothing but, I just change the color. Yeah. C is equal to epsilon naught A by D. This formula we already know in this chapter. Correct? It has got a capacitance of how much? 10 picofarad. So that is my 10 PF. Correct? Then the capacitance, if the distance between the plate is reduced by half. So this D is becoming what? D by 2. Then it is filled. The parallel plate capacitor is there, right? Two parallel plate is filled with the dielectric constant of 4. So in the sense, what is my C2? K into epsilon naught A. Instead of D, it is by half, D by 2. Correct? And what is my K given? What is my K? Dielectric constant. Yes, that is my dielectric constant is given. What is my epsilon naught A by 2? Oh, sorry, epsilon naught A by D, 10 picofarad. Already I know the value of that. So K is 4, 4 into 10 into 2. So 80 picofarad. Direct answer. Option A. Is it easy? Just substituting what is epsilon naught A by D. C is equal to epsilon naught A by D. Is it easy now? So if you know this, hardly 20 to 30 seconds it will take. That's all. And guys, the champions, I'll be just doing it little bit fast. Okay, so that we can do maximum number of questions. And once it is done, I'll help you out with everything. Okay, so no need for you to panic or worry. I'm there to help you out. Fine. Yeah. Just clear it out. Third one, a 400 picofarad capacitor is charged by 100-volt supply. How much electrostatic energy is lost in the process of disconnecting from the supply and connecting another uncharged 400 picofarad capacitor? Okay, so this is a pretty much big question. Okay, and which requires a lot of step. Let me see whether I can put it in a whiteboard or something. Yeah, I think you guys are able to see the screen, right? Yeah. Say 400 picofarad capacitor. Let me just see whether I can able to put it in a word. Just give me a moment. So yes, I think you're able to see a screen, right? You're able to see a screen. Say 400 picofarad capacitor. Yeah, perfect side. Is charged by a 100-volt supply. How much electrostatic energy is lost in the process of disconnecting from the supply and connecting another uncharged 400 picofarad capacitor? Okay, I'll just share the word. Now let me see whether I can annotate here. See, first thing is we should know what is the general formula of this. Q is equal to CV. Correct? Yeah. So when the capacitor is connected to an uncharged capacitor C2, the charge flows and both attains a common potential V. In the sense, what is my V from this diagram? V is equal to Q by C. Correct? So now my Q is basically Q1 plus Q2 and C is my C1 plus C2. Go back to this question. Let me just open. Yeah. So in the question, we are having how much electricity energy is lost in the process of disconnecting from the supply and connecting another uncharged 400 PF capacitor. In the sense, for the second charge, it is 0. The Q2 is 0. And C2, what is the value? 400 picofarad. C1, what is the value? 400 picofarad. C1 is 400, C2 is also 400. But the charge for a secondary is what? 0. Okay. So now coming back to the question, the word where I done it. Yes. So the triangle again, I'll draw it. Q, C, V. Correct. C is equal to Q by V, or V is equal to Q by C. So I'm just taking this particular thing. So what is my V is equal to Q1 plus Q2? Q2, I just told you it's 0 because it is not connected. So charge is 0 by C1 plus C2. C1 and C2 value is 400 picofarad. Correct. And what is my Q1? Not given. Correct. So if Q1 is not given, what is Q value? Q is CV. So Q1 is nothing but what? Q1 is C1 into V1 by 400 plus 400 is 800. 800 picofarad, 10 power minus 10. C1 is nothing but, what is my C1? 400 picofarad. Okay, 10 power minus 12. 10 power minus 10 is Armstrong. 10 power minus 12 is picofarad. And 10 power minus 9 is nanofarad. Okay, picofarad is 10 power minus 12, not 10 power minus 10. 10 power minus 10 is Armstrong. So, and V1. V1 is also given in the question is 100. So 400 into 100 by 800 into 10 power minus 12. Once you solve it, I'll be getting 50 volts. That is my voltage. That is my voltage. I'll be getting 50 volts. Fine. So once I'm getting the 50 volts, the question here is what? Final energy stored in the capacitor. Okay, the final energy stored in the capacitor. So for that, I'll just clear everything now. Yeah. So we know U is equal to half into CV square. Correct. But how many capacitors are here? Two are there. Half into C1 plus C2 into V square. This is half into, what is C1 plus C2? 800. Correct. 800 into 10 power minus 12. Into V square is 50 square. Just know what we calculated. So once we are doing this, we'll be getting an answer 10 power minus 6 joules. I'm going a little bit fast so that we'll be able to complete more questions. Please don't worry if you're not able to follow it. Again, I'll come and help you out on the same questions. But those who are able to get it, good. If you're not able to get it, also no need to panic or worry. I'm there to help you out. Okay, so we can mark our option. So I'm just clearing it now. So I think you'll be able to see the next question. I'll take an easy question now. Fifth question. Consider the following statements about the electric dipole and select the correct ones. First statement. Electric dipole moment vector P is that from negative charge to positive charge. Okay, negative to positive. Charge is moving from what? Negative to positive. Second one, electric field of dipole at a point with position R depends on mode R as well as the angle between R and P. Third thing, third statement is electric dipole potential falls off as 1 by R square and not as 1 by R. Last statement, in an uniform electric field, the electric dipole experiences no net force but a torque tau is equal to P cross E. So first thing is, already I have told you in the sessions, charge, correct, negative charge. So dipole moment vector P is that from negative charge to positive charge. Yes, on the first chapter itself, we have electric field and charges. Electric pole dipole moment is what directed from negative charge to the positive charge. That is first statement is correct. So, and then if I take all other statement, so everything is correct. So it's all four. Option D is the correct answer in this. And one more thing is in unified electric field, the electric dipole experience what torque. Tau is equal P cross E. P is sin theta. S4 is also correct. So first and four is correct. So we need not even think about other things. So option D is the answer. Sixth question. Can you guys try it? Or how many of you need my help? Let me know. Then I will do it. Just if anyone need my help, just put in chat option. If anyone is needing any of my help, please put in chat option. Sahana, Prithvi, Sahid, Kaustub. If you don't know, let me know. Do not talk to each other. Okay. See, current electricity problem. I have told you that if it is in parallel, correct? So coming to this question, I already told the current electricity how to do it in series and parallel. So in capacitance, just like the opposites of resistors. So if I can see here, two capacitance are what? In series. So in resistance, what we do? Series we will add, right? Correct? In capacitance, we should do what? This is 1 by 2 plus 1 by 2. But also one more trick which I shared is, if the value is same, both are 2 microfarad and 2 microfarad. Then in current list, I told you just do R by 2. So here also you have to just do what? C by 2. So what I'll be getting in place of this? 1 microfarad I'll be getting. 1 microfarad. Clear? Yeah. So first step is to minimize this thing. So I'll be getting 1 microfarad. So instead of this, what I can put 1 microfarad. Then just drawing the same thing here. This is my 2 microfarad. And this is again my 2 microfarad here. Correct? So this is also in series. So this again will become 1 microfarad. Then I told you in the junction. Again, current electricity in the junction, if the current can flow in, how many ways here? More than, current can enter or leave more than 3 ways. Then again, it is in parallel. Correct? Again, this is in parallel. In the sense, how will I draw this thing? I'll show you it in the word. Or let me see whether I can go to top. I think this will be fine, I think so. So that I can draw it a little bit neatly. This is my C microfarad, okay? Yes. They're not given anything for this. And this is my 1 microfarad. And this is my 10 cube that I'm least bothered about it. I'm only worried about how to find the capacitance in series or parallel. So coming to this, again to redraw this entire thing. correct? So this and this is in parallel, or I can take this and this also in parallel. So in this case, I'm taking this and this in parallel because current can enter or leave in three ways. So the same concept, correct? So again, if it is in parallel in capacitance, what should I do? I should add in capacitance for parallel. I should add, correct? So what I'll be getting C plus 1, and that is parallel with this 1 microfarad. So what I'll do for that? 1 by C plus 1 plus 1 by 1. So then cross multiplying the same thing. C plus 1 plus 1 by C plus 1 is equal to my 1 by C equivalent. Yes. So once I am getting to that, C plus 2 by C plus 1 I'll be getting. C plus 2 by C plus 1. So what is my C equivalent? C equivalent will be C plus 1 by C plus 2 respectively. Now coming to the question. Let me go to the question. Yeah. When a potential difference of 10 cube volts applied between A and B, a charge of 0.75 millicoulomb is stored in the system of capacitors and shown. Correct? So same concept I'm going to use. Q is equal to CV. Q is equal to CV. The triangle. Only one triangle we have. That is this. Q is equal to CV. So capacitance already I found it out. Correct? C plus 1 by C plus 2. And capacitance value is what is given. See, 10 cube volt is applied between A and B, charge of 0.75 millicoulomb. Correct? So capacitance only I have to find out from this. But the capacitance what I just now found out is C plus 1 by C plus 2. And what is voltage given? 10 power 3 into 10 power 3. And what is my charge? 0.75 millicoulomb. So 0.75 into millicoulomb, 10 power minus 3. Correct? So once I'm solving everything, I'll be getting the capacitance value as 2 microfarad. Once I solve all the equations.